Hi everyone, my name is Sashvia Chaudhary, and in this lab, I analyzed the motion of two pool balls colliding. The main objective for this lab was to show what type of collision occurs between two pool balls, as well as to see whether the velocity of ball 2 would be the same as the velocity of ball 1 after collision. So my main results were that inelastic collision occurs when the two balls collide because delta K, or the change in kinetic energy, is different before and after collision. Also, the velocity of ball 2 is greater than the velocity of ball 1 after collision. So the main physics ideas pertaining to this system, which consists of the two pool balls, was the momentum principle as well as the energy principle, where delta, or the change in energy of the system, is equal to the work done by the surroundings. Here the work done by the surroundings is zero because no external forces were applied on the two balls after the initial ball was let loose. So I obtained a video of the two balls colliding, and I analyzed this and I analyzed their motion on tracker. So first I tracked the motion of ball 1, which approaches from the left, and I set the origin to be at the center of the stationary ball, which is shown here, which is ball 2. I calibrated the radius of ball 2, which was 0.028 meters, and I found both balls to have equal masses of 0.16 kilograms from the internet. As you can see, as ball 1 collides with ball 2 moves away quickly, but the first ball loses momentum. So I modeled this motion in my Python code, where I put in my data of the masses and starting times, as well as my initial position data for both balls. My initial position data is right here, and this is the other data. I also had my iterative loop update all my position data points as we've done before in other labs. So here's my iterative loop. And so here's a run of my model. And as you can see, the red ball moves relatively quickly and collides with the blue ball and slows down a little, and the blue ball moves faster. So the final velocity of the ball, the final velocity of ball 1, which is the red ball, is 0.3125 meters per second, whereas the final velocity of ball 2, the blue ball, is greater than the ball 1's velocity and is 2 meters per second. This is the predicted final velocity of ball 2. So the model is based mainly on the model is based mainly on the conservation principle of momentum, where m1 v1 initial plus m2 v2 initial equals m1 v1 final plus m2 v2 final. And this is shown here in my code. At this portion of the code shows this, which helps update the change in momentum of my system. I also used the momentum principle to predict the final velocity of ball 2 after collision, and I made Python print the final velocities of ball 1 and ball 2. To check whether the model predicted this accurately, I tracked the second ball's motion, which is shown here. As you can see, these are the blue points. So all the blue points are the tracking positions for the motion of ball 2. And then I used this data to check the model data, or predicted data. So this is what I found. I found that the predicted data was slightly faster than my observation data, which showed that ball 2's velocity was 1.375 meters per second, whereas the model predicts it to be 2 meters per second. My model neglected the force of gravity as well as friction, which is actually accounted for in the real-life situation, and I believe this is the reason for discrepancies. Then, using the final velocity of ball 2 from the real situation, which I found with the momentum principle, I also found the final and initial momentums of balls 1 and 2. Then, using the energy principle, which is delta E of the system, is equal to 0, where delta E equals the final kinetic energy minus initial kinetic energy equals to 0. This is the situation which occurs for elastic collisions. So that means the final kinetic energy must be equal to initial kinetic energy, which is shown here. So basically here are the equations which are used to find the final initial kinetic energies of the two balls, and so from these calculations it is seen that the initial kinetic energy and the final kinetic energy are not equal to each other. Therefore, this must be an inelastic collision because the kinetic energy differs before and after the collision. Well, thank you. That was the end of my lab, and thanks for watching.